Okay, so far we have built this program in LabView, the tank problem. I want to show you some other things in this program, some basic things about LabView. I think doing this on this simple program is really helpful. Remember when we were talking about LabView and I showed you that there are some other icons here that I will talk to you later about them? So this is the time that we're going to talk about them, actually. So here, if you click on this is an align objects. So if you want to make the front panel looking like nicer and more beautiful and more aligned, you can use these icons. For example, you can select all these controls that we have and then click on align objects and then align them all on the left. Like you can see that there are different icons and objects and they are aligned all on the left. So if I click on this, it's going to align them all and then put them all in one line and make them look nicer. I can either maybe have this also, the Boolean function here, and then you can move the tank here and we can do the same thing for this. So there are different things that you can align and you can decide like how you want to do them. For example, say that you want to align all of them in a way, actually say that you want to align this. I'll hit a control and select, oops, sorry. This is interesting. So if you select something and then click on control, you can move things around like this. I didn't know that. So basically what I did is that select something and then click control and select whatever like option in whatever location that you want, and you can move things around. These are all for for making things look nice. And so yeah, there are too many different things that you can use and then align your objects in your front panel and then make them look nicer in your program. So there's another thing that I want to tell you. So say that you want to put a box around all of these controls and give some titles to it so the users know what to do when they open their LabView. You can right click and say choose a decorations and choose whatever decorations that you want. I'll choose the flat box for now. And then you can make a box here and you can see that the box is on top of the controls and they're not showing. If you select this, there is this icon here says reorder. Click on it and say move to back. So you basically moved it to the back. Say you want to add a title to it now. Again, select go to the decorations and then select the label and type here, please update the values in this box, for example, something like that. And you want to change the format of these typing things that you have here. You can go to here, this part, text setting, and you can change the size, for example, to 18, and you can justify it, and you can change the color, so many different things that you would like to play with it. You can bold it and all these things. So this is some formatting and making your program beautiful. So you can do some other things also, like if you want to tell, okay, this part is the initial input and here is your results, you can add box and have labels and then define them. So I will add I'm not gonna continue adding box and making this program beautiful. You can play with this and make it as beautiful as you want. Give enough information so that the user, when they open the LabView, it's so easy for them to follow. You can, for example, add a text or label somewhere here, and then give them some, some information, like when you open the program, here are the tips. Please fill this first and do that first, and then click on the arrow and run it, and if like this arrow here, and if you want to stop the program, you can stop the program in here. So you can give enough information so the user will understand what to do when they open the program. So now let's say that you want to change the color of this box that you have created, just to make it aesthetically look nice. You can come to the tools, the view, and then choose the tools palette. And here at the set color, you can define whatever color that you want, and you can see this brush here, and then you can change the color of it. So yeah, depending like which layers, it has like 2 layers. Whatever layers of colors that you want to give to it, you can change the color of it. This is also something interesting, but just keep in mind, if you do that, if you don't click on this automatic tool selection, it will keep the brush with you. But once you have this automatic tool selection on, then again everything will be automatically changed, and it will be interactive, which will be way nicer for you to play with. So yeah, these were something about like making the front panel looking beautiful. I'm not gonna tell you like everything that we can do, but there were just some like introductory thing about how we can make it look beautiful. You can explore more and play with it based on your needs. There's something else. So now we have made the block diagram the front panel, look nice. Now let's make the block diagram look nice. So in the block diagram, we have something that is called a cleanup diagram. So if you click on the cleanup diagram, what it does is that it will look at your entire program. Let me make it larger. It will look at your entire program and will try to clean it up and make it like look smaller, and doesn't occupy the entire space. So let's click on it. Just notice how it's going to change. See, just basically move things around to have them like a little bit looking cleaner. You may like it, you may not like it, but I will control Z so you can see like it was larger, and once I click on this, it makes it look like a little bit cleaner. So this is something that you may like it or you may not like it. You may do it or you may not do it, but I thought that it's useful for you to know. So now let's say that you want to add a text box here with the information that this program is giving you. Like you want to write time left to stop the pump is, for example, 2 minutes. There is some express VIs in LabView which are really useful. And what express VI actually means that it already have some like calculations and some functions built inside of them, and it will help you a lot with programs, so you don't have to write and code everything in, because there's some information that is already there are some function that has already built to do the specific task that you want. So if you right click in the block diagram and go to the Express tab, in the Express tab go to the Output, and there's one called Build Text. So whenever you have an Express VI, you will have this like light blue box around it. That means that there are some functions already built. I will open it for you and you will see what I mean. So once you open it and you put it here, you can see the blue box around it. This is for sure an Express VI. And another window opens for you. This is what happens inside this box. It means that it's like a simple, small VI that has already been built. And what you need to do is basically, this is your front panel. You just type in what you want to do, and then the function will be built up for you. Here it will give you some like tips, like it says text with parameters in a percentage. So it's telling you write your parameters inside the percentage. So I'll say time to stop the pump. I'm just gonna give a name to this express VI, and you can see it's printed here, and I'll click just OK. So now my express VI is built for a specific need that I want. So what it does is that it basically asks you for a beginning text, and then you can give a number to it, and it will merge the text and number to both of them to each other, and it will print you the results. Say I want to do this inside this this case structure, because whenever I have the tank hasn't been filled yet, and I want to know like how much time I have left, I want this express VI here to type it for me. So I will move things around a little to make a room for this, because I already cleaned it. So this is it. So here I will right click and create, and instead of going to control and indicator, I'm just going to use a constant, because I'm just going to give it a constant number, a constant text, sorry. So I'm going to say that time left to stop the pump is. So this is what I'm going to say. So what this express VI will do is that it will say time left to stop the pump is whatever minutes that I have left in here. It will give me the results. So this is the result, the time left to stop the pump, right? So this is, you can see it has an orange color wire to it. That means that this is a number, and it's a scalar. This is a numeric value. But notice here that for the text, we have it in purple color, pinkish color. So far we have learned 3 different colors. An orange color, which are numeric numbers, a green color for wire, which is a boolean, it's either true or false, and we have a pinkish color, which is for text and for strings. So string is another name for text in programming. So this requires, like here you can see it's pinkish color, it means that it requires a text, but that text can be a number. So I cannot connect this to this because this is orange and this is pink, so it's not doable. I need another function that transfer my number to a text. So basically what this express VI does is that it's going to merge 2 texts to each other and give you one big result. You will see what I mean. So what I need to do is that I have to transfer my number, or my floating point, which is orange, my scalar number, to a text or to a string. So if you right click here in the string function, there is a function called format into string. So you click that and you put it somewhere in here. So it will ask for the input 1. So input 1 is your input of a floating point, which is orange. Notice that the circle here is also orange. That means that it only accepts orange, or a floating point, or a number. So but here you have like pinkish points. That means that here for these 3 it only requires a string. So what this function does is that it will get this value in a floating point format, and then give a string result, which is pinkish, and then I can connect this to the time to stop the pump. So, and I will have a result. So for the result, you can go to create and an indicator, because this is an output. You want to see that this is an indicator. So now let's run it. Because this is time left to stop the pump, I will change the time to 5, something that I know that the tank is not full, and then I'll run it. It says that time, so you run this and you know that the data from before, but this is the what the results does is that it says time left to stop the pump is 2.5, right? So this basically, this is what this express vi does. It's gonna merge these two and give you one big string or text. But this is not perfect. You don't like it this way. Here we have another, like there are some other output that goes out, and you can define them and change them. And here is one of them, is format string. Right click, create, and go for constant. So when you type a string, there are some way that you can play with the formatting of it. So if I type percentage, so I will not do it like this. I will click on it and I will go to help, so I will show it to you better what I mean. So you open the help, and this is going to show you what each of these circles mean. So this is an input. You can have several different inputs, and you have your format string, and you will be your result. So in the formatting string, if you go to format string and click in here, it's gonna guide you through like how to do the formatting. So you can read through this, and here for the floating point which we have, if you go percentage %f, here are some example. So for example, percentage 5.1f. That means that the 5 in the format string section specify a width of 5. It means that it will give you 5 spots as a space. And then once the 1 here specifies the number of the digit to the right of the decimal. So this is for the floating point. The 5 give us the space, and the 1 is the number of decimals after the on the right side of the digits. So here I'm gonna type percentage %f. Oh, it's not typing. I'm gonna type percentage %f, and for example, I'm gonna say 5.1, exactly like the one that it was in the example. And then I'll run it again. Just keep looking at this and see how this is gonna change. Sorry, I made it right. It should be 5.1 and then an F. See, I made a mistake. Now look at this and see how this is gonna change. You see that there is a space here. So before there were no space. Like if I delete that and if I run it, oh, there is an error because I have to write something in here. So yeah, I delete that and I'm gonna run it. So you can see this is it without any formatting. But if I format, create, constant, and type in my formatting thing, I'll bring it down so it looks nicer. And now if I run it, now notice how it's gonna change. There is a space here, which is basically this 5. It means 5 spots as a space. And then dot 1, that 1 means only one number on the right side. So if I, for example, change this to 3, you'll see how the decimal changes. But because we also have the 5, it starts filling from the right, so the space is gone. So now you have to, for example, type a bit larger number here and then give the space. So this is how you can play with it. So now we have, let me change it to 8, it looks nicer. So now we have typed in for the user, like when user comes and look at all these things, maybe it's confusing for them to say what this means. So you can type a text to give more information to the user that the time left to stop the pump is 2.5, but you need a minute also after that, because 2.5 of what? So you can add another one of these. So you can Control C and Control V, or copy another one of them in here, and you'll just keep your results for this part. So you will connect the result to here, and now we have time left to stop the pump is 2.5 And now what? You need a minute. So the result of this will go to your beginning text, because this is your beginning of the text. And then you will need a create constant, a minute here. So this, the result of this will be added to the minute and give you the final results. But let me run this. Look how it will look in here. You'll have the minute here without any space, which you may not like it, or you may. So another way that you can do it, which is a really simple tricky test, is just to add a space in here. That's it. And now I'll run it and you can see. See, there's a space here. So simple, easy. So what this ExpressVI did was that it's an interactive text building machine. So it will look at your result, it will look at your program, look what the results of this value, this numeric is, and change this value of this numeric into a text and type it here for you. So now let's say that I type 7 in here. See how interactive it is. It's not going to be 2.5 anymore, but it's going to be another number, which is 0.5. So basically, this ExpressVI helped us build a text which is so smart that will look at the results of your program. It's not just you typing a text and always print that text, but it's a smart text builder. So what I want to show you was that we are having some ExpressVIs that will make your life way easier, and I recommend to use them because it will make your program clean. It will help you. It will not make your program really complicated. Sometimes there might be some errors with them, but as long as you're not doing a really huge, big, complicated programming, this is the best. Unless you're doing something really specific that needs a lot of like detailing and stuff, then it's better to always make your program from scratch. But other than that, you use ExpressVI and it's going to be really helpful for you. So we are still building up in this program, and I think it's gonna be it's really helpful. I'm gonna do more examples, but this is just one example. But during this example, I feel like it's really interesting that I can show you different functions and different applications of LabView. So you will learn as I go. I think examples are the best. So now say that you don't want to type different numbers every time for time and run, see the results, and then again run and see the results and everything. But you want a program which is interactive, and as long as you type the run, you can change the time and see the results always. To do that, we need a loop. So let me make this larger. We need a loop, a for loop or a while loop. So again, why we need a loop? Because in a loop, a certain program will happen until a certain constraint is met. So here I'll right click here and go to the structures, and this time instead of like the case structure, which I already showed you, which is an if statement, an if clause, this time we are having a while loop. I'm going to choose a while loop, and I'm not going to choose a for loop here because I think while loop is the best for this case. And I'm going to show you why. So you select a while loop and you come and put everything inside a while loop. So all the programs, even the one, the first stack one, this is also in the while loop. So everything is in the while loop. So just notice how the arrow is crushed here because you added a while loop, but you haven't defined a stop button here. So I'll show you. So in the while loop, if I go to the help, I want to show you what it is. So we are having the interval. So basically this will, so not the interval, sorry, the iteration number. So it's basically reads you the iteration numbers, like how many times the while loop has been run so far. And this is the stop button. So, and everything inside the while loop will happen as long as you stop it or certain constraint is met. So this is the iteration number, and here is the stop button. So I will right click here and create a control. So if I double click on this, this is my control, a stop button. So instead of a user come and stop it here, you can stop it here. As we move forward, I will show you that you might not have a click, but you might have a certain constraint. So for example, you can say that if the volume of the tank is more than 17 liter, stop the program, something like that. So you can have that connected to the stop. This can also happen, but for now, just say that we have a manual stop button, that the user comes and stop the button and the program will stop and end. So this is a while loop. And now you can see that the arrow is white again because we have already met a constraint here for the stop. This is not important. You don't need the iteration number to have a perfectly made program. You can use the iteration number if it's needed in your program, but it's not something that is absolutely necessary for the LabView to have it so that you can run the program. So yeah, something this simple. And now say that you want to run this. So we have a while loop, and this program will run as long as someone stop the button. So this means that always run this program in the while loop until someone come and stop the button. So now I'm gonna run this, and I'm gonna show you something. Like, look at this. So this is running, and you can see like how fast this is running. It's so fast running. Like after 7 minutes, we have 0.5 minute left to stop the pump, so the tank is not overflowed. So now if I say 8, and now a different situation happened. The tank is already overflowed, and the volume of the overflow is 1. So you can see like how fast it's running. It's like running so much and so fast. But it's interactive, like I can say 10 and then click, and this is changed. So when you type a number here, you have to click so that this run for the next one. As long as you stay here and don't click anywhere, it's not gonna change, but you have to enter or click or do something so that number is readable to the program. So this is so fast. It's taking so much of the RAM of your computer, and it's not nice. So now let's stop it. You can click on stop here and then stop the program. So you're telling the program to do this while loop as long as someone click on stop. So it comes here, starts running until somebody stop it. I'll turn on the light bulb here and I will show you what it means. So it goes first here, starts running it. And you can see how it's just going to different paths and printing you the results and everything that you want. It's small, it's slower than the actual run because we have turned on the light bulb there. But it just keeps running. Say now is the second iteration. It's just running it until it's done. You can either click on the stop button here too. So now I will create in the number of iteration, you can right click and create an indicator so that a user can see how many iteration number it has been running. So I'll give you this indicator here, and I will type that this is the number of iterations. And now if I run it, I turn off the light bulb so it will run fast again. And you can notice like how fast this is running, like how fast. Oh my god, it's so fast. You can see it's running so fast, and we don't like that. So how can we slow down the program from running? We need another function that slows down the running of the program, and that's so simple here because somebody has already thought about it and built a function for you. So you need to right click and then go to timing and wait. We need a wait time so that we can wait and that the while loop doesn't operate so fast. You have to put the wait outside this flat sequence, the stack sequence inside the while loop. So what it means that it will run the while loop for the first iteration, wait for that specific amount of time to meet, and then go and run the second one. So in the wait, we have a milliseconds to wait, And then for the left side, you will right click, create a constant, and I will give it a constant number of 1000 millisecond or 1 second. So basically what it means that it will run this while loop, it will wait 1 second or 1000 millisecond and run the second loop, and then the second loop and second iteration and so on. Now I will run it, and now notice the number of iteration here. 1 second, 2 seconds, 3, 4. So now it's not running so fast. It's just giving it 1 second time for the program to rest and then run the second one. And now I can type different numbers here, and you can see this is not flashing, and it's just giving me data really like nice, and it's quiet and peaceful and all these things. So it's just so easy, and it looks way more professional and look nicer. And so a user can come, run, give different values to the time, see the results, type in the results, and then whenever they're done, they can either stop it from here or from there and then stop the program. I will save the program. So yeah, that was also another thing that I want to show you. So far you have learned a case structure, which is an if statement that tells you if a certain constraint happens, what should I do? And then for the if statement, you have a true or false. So you have to connect this case selector to a Boolean function and says that for a true case, do this, for a false case, do that. I also showed you a sequence, which could either be a flat sequence of windows, that will run the first window first, then goes to the second windows and third windows, or you can have them stack if you don't want to use a lot of space in your program. And so this way we made a little trick that we basically in the first stack of the program we make the indicators or the outputs as 0, so it will not confuse the user. And in the second window of the sequence function, we run the real program and do whatever that we wanted to do. And also I have showed you what is a while loop. That while loop, it means that everything inside that while loop box happens as long as a certain constraint is met. And here for us, a certain constraint is the stop button. And again, notice here that this wire is green. It means that the stop either has been clicked and is true, or it hasn't been clicked and it's false. So whenever we say a constraint, we mean a true or a false, or a green wire to be connected. And I've also showed you when a while loop is operating, like how the iteration number and the number of iterations. And I showed you that if you don't add a wait function, this will run so fast, and it takes a lot of the RAMs, and for your very big and complicated programs, it will crush your program. So it's good to always give it a wait so that the buffer gets clean in the computer, and the computer can just rest a little and understand what to do next. So that was a wait function. I also talked about some express VIs that they are in blue boxes. That these blue boxes, they already have a built-in or kind of like a sub VI inside of them that people in the National Instrument, they have built this express VIs for you so that you can just program your things a little bit easier and create functions for you. And I also talked that whenever you see a pinkish line, this is a text or a string. Whenever you see an orange line or an orange box or whatever, like these are also orange, that means that this is a floating point and it's a number. And whenever you see a green wire, that means that is a Boolean. It's either true or false.